Hi, everyone, and welcome to Lithuania Goes AI, a series of virtual events about the Lithuanian AI ecosystem and the current innovations in AI. Today, we are having already the third event out of 5, and Lithuania Goes AI. Today, we are talking about defense, security, and space. The uncanny valley of and conspirative nature of these three fields, defense, security, and space, fascinates everyday normal citizen just like me. Because of the complexity of these topics, outsiders are easily expelled and sorted from insiders, and that just makes it more appealing. And if you add AI to this spicy mix of cybersecurity, defensive matters, and exploration of space, you get a lot to wonder about and to fantasize about. Also, with billionaires flying in space and security issues being a constant novelty, who could say that it's not a good time to talk, to just get to know more about these topics? So that's what we are about to do here today. I guess some of you have been to some other Lithuania Goes AI events, so you know how it goes. Today, we want to learn what is happening in Lithuania in these three topics. Who are the main players, the new innovators? What are they up to? How are they doing? And how do they see the microclimate of doing business in Lithuania? We'll talk about this in our discussion at the end of this event. As I said, if you've been to Lithuania Goes AI, you know how it goes. It's not too formal, kind of friendly, and everyone is invited. So Mita and Lithuania Goes AI invited businesses and startups from all over the world to join and learn about all these three topics from the insider's perspective. So hopefully you are joining, you are enjoying and learning. Let me know in the chat, as always. Are you alive? Are you listening? Oh, Sorana, Philip is already saying hi. Hi, Sorana. As always, we use chat to communicate. You can ask questions, you can share your stories there. After every presentation, we are going to have a 5-minute Q&A with the presenters. So as always, feel free to ask whatever you like and be involved. My name is Lukas Karaitis. I'm a science and technology communicator. I work with TV and radio shows in these topics. I am interested in this topic myself for quite some time now. LRT Plus Mokslo Sriuba, one of the shows you might seen time into, Žinių Radijas, and the shows on the radio. Dubitai is the new one I'm working on now, covering weekly technology news there, and basically I am quite involved in these events and ecosystem here in Lithuania. Just a curious person who likes to ask a lot of questions. So yeah, that's about it. Daiva is saying hi. Hi, Daiva. I'm wondering if you could say, where are you from, which country or which company or institute or which field of interest are you from in the chat? That would be great. Last time we had someone who just said that she's writing fiction novels about AI and was interested in the topic. That was super interesting to hear. So you can just share where are you from and how are you involved with AI or the topics. So yeah, we are going to start with 4 presentations. One is more interesting than the other. From 4 Lithuanian companies are going to present us, and we are going to start with Domantas Čiuldė, CEO and co-founder of Idenfy. Idenfy is defeating fraud while processing customer data quickly and securely using the latest AI and biometric technologies. Basically, it helps verify identification. So it's a company I'm hearing from for the first time. So I'm super curious to hear what Domantas has to say about the role of AI in prevention of fraud and money laundering. That's the topic he's going to talk about. So yeah, everyone is saying hi. Diana is saying hi. Sorana is saying hi from Romania. She's conducting research at the University of Sheffield on the topic of AI, critical success factors and innovative approaches for European startups. So good to have you here, Sorana. Thanks for sharing with us what you are up to. And Domantas, as I presented. Hi, Domantas. I can see you. Can I hear you?
Hi, Lucas. Hi, everyone. Thank you, Lucas, for the introduction. Yeah, so as Lucas mentioned it, my name is Domantas Čiulda. I'm CEO and co-founder at company Identify. So today I would like to talk about what role does artificial intelligence play in the prevention of fraud and money laundering. So firstly, I'd like to introduce what services we are providing and why the artificial intelligence is essential for us. So firstly, we are providing biometrics recognition service. So I mean face recognition. So we are comparing two faces and we find out what the similarity is between the two faces. Another thing what we're doing is remote identity verification. So basically we are scanning the face, taking the selfie remotely and taking the picture of the identity document. So we compare the face from the document with a selfie face, and we extract the data from identity document, and we validate the data. We validate if the document is real or it's not real. And this is how we verify the person remotely. As well, we are providing fraud detection and prevention services for the companies who are dealing with credit card fraud or fake accounts. So we are providing these services to prevent from such activity. And as well, we are providing compliance services, anti-money laundering services for the companies which must comply with regulations. So as well, we provide these services. So in all these mentioned services, we are using artificial intelligence. And I could say that artificial intelligence is the main ingredient for all our products. Yeah, so how much artificial intelligence we use? So basically, we don't use 100% artificial intelligence, but we use 80% artificial intelligence in our all products, and 20% is human. So we supervise all the processes which done artificial intelligence by the human. So here is a couple of functions which we do with artificial intelligence. So identity document recognition, identity document security elements verification, font recognition, optical character recognition, face recognition, liveness detection, negative news, and customer risk scoring. So within all these services, we use artificial intelligence. As well, we have more services, but I would like to talk about these today. All right. So by moving forward, so how artificial intelligence help us? So by taking the first task, for example, what we need to do daily, we have to identify identity documents. There is a plenty of documents in the world today. So there is around 200 countries and territories, and we have more than 2,000 documents. So like passports, driving license, residence permits, and others. So we need to identify from one photo to which country this document belongs, how this document should look like, how the government issued the document template, and what security features document must have. So to do that for the human, for employee, it's really hard task. And in this work, we employ the artificial intelligence. So by having the photo of the ID document, we can instantly say to which country it belongs, where is the security features must be placed, how this document should look like, when it was issued, and when it will be expired. So artificial intelligence really help us on these daily tasks for us. Another thing, how artificial intelligence help us, so to recognize which document is real and which document is fake. So here I have a picture of two documents. Basically, it's the same document, but one is real, and in another document, the information is changed using image manipulation program like Photoshop or GIMP, and we need to recognize which document is real. So for the human eye, it's really complicated task. I could say that it's impossible, mission impossible to do that. But by employing the computer vision and artificial intelligence, we can detect which document is real and which is fake. So as you can see in the left side, there is a real document, and after applying computer vision filters, we can see there is not a lot of anomalies here. But on the right side, there is fake document. The information was changed using Photoshop, and we can see that there is a lot of anomalies, highlighted parts in the document. So by attaching computer vision to artificial intelligence, we can automate this process and instantly say which document is real, which is not. And by comparing with a human, it's really impossible task. As well, artificial intelligence helps us with one of good features how to recognize the document validity is font recognition. Because maybe not a lot of people know, but governments are using special fonts. So I mean special fonts that we are using the standard fonts like Arial, Verdana, or Times New Roman. But we are changing a little parts in the font. For example, we are taking one part of a character and just making it a little bit different. And this is how, after the examination, we can say if the font is the real or not, because we know how the characters must be. Yes, and yeah, so this task for the human would be really hard to know 2,000 documents, to know which fonts and which parts of a characters must be different. So we employ in this task artificial intelligence, and that helps us to recognize the fonts, which parts are real, which parts are not, and this is how we can detect if a document was faked or it's real. Yeah, because fraudsters who are faking the documents, in most ways we do not pay attention in such things. So we are using the similar fonts, but we are not changing characters details. So this is the good security feature how we can catch the forged documents. Another good thing is, I guess everyone knows, optical character recognition, but it's really old function and it's widely used in everywhere. But such function helps a lot in our processes, because we need to extract the data from the document, like name, surname, document number, expiry date, and all other important information. To do that for the trained employee, it took around 45 seconds to extract all this information from the document. But by employing the artificial intelligence here in this process, we can extract all this data in 0.02 seconds. So to compare how this OCR function save us resources and costs. So, for example, while the employee extract the data within 45 seconds, with OCR technology, we can extract the data from 2,250 documents in the same time, in that 45 seconds. Right, moving forward. As I mentioned it in the beginning, we are providing the biometric recognition services, but here I would like to talk about a little bit different function and how the artificial intelligence helps us. So we have cases when the fraudsters are using really advanced fake documents, and it's mostly impossible to recognize this document real or not remotely. So the only thing that we are using functions like liveness detection, and mostly the fraudsters are using their face for verification, but we are using different identities. So I mean, in one bank where we open account, let's say with their face and with one identity, yeah. But in another bank, we open the bank account with different identity. We use different paths with their face, and we need to catch such cases. So we have a task to find the face, one face between the millions faces, yeah. So we here employ as well artificial intelligence algorithms to find the one face between others. And for example, we have, let's say, 10,000 identities, and we have that the same person has 5 different identities with that 10,000. Yes, so we employ the artificial intelligence, and we can within seconds find how many accounts we have as well with their face with different identities with other organizations. Yeah. Another good thing as well, how artificial intelligence helps us within daily tasks is to recognize the face spoofing attacks. So the fraudsters, what we're doing here, so we are trying to fool the biometric recognition system by using face spoofing from the printed on the paper or from the mobile phone. So the process looks like that when we found the identity document lost or stolen, so we use the identity document, and we don't have the picture of a face, because we need taking the process to take the picture of a selfie and the picture of a identity document. So we are trying to somehow to find the owner's face on the internet, in the social networks. So we download that face, we try to print it on the paper. Let's say it's called 2D presentation attack. So we print that on the paper, show to the biometric recognition system, and this is how we try to fool. As well, we have more sophisticated attacks like the 3D presentation attacks. So in such attack, we use 3D masks. So we print with a 3D printers the face very similar to the owner face, and this is how we use to fool the biometric recognition systems. The most popular way is just to download the picture from the internet and to use from mobile phone or from the tablet, and in such way to fool the biometric system. Here is the diagram how the process looks like. So we're taking the picture, we're showing the picture from the mobile phone to the biometric recognition system, and in such way are trying to bypass such authentication. But employing artificial intelligence, we can find out some noise, and with another algorithms is the face real, or it's showed from the mobile phone, or it's printed on the paper, or it is 3D mask. Yes, and so for overall, artificial intelligence helps us to eliminate the fraudulent transactions, to make the process faster with better user experience, to do things that are impossible for human to do, and to deliver the service at lower rates. So in overall, I could say that without artificial intelligence, such service like ours won't exist. So yeah, so thank you for your attention today. My name is Domantas Čiulda. Here is my contacts. If you want to discuss more deeper about artificial intelligence, I'm very happy to do that.
Yes, Domantas, thank you very much for an amazing presentation on amazing product that you have and you're working on. I was listening carefully. I can see already some questions in the chat, but I just want to begin with, and just to be clear, so who are your customers? Are these governments, and what could be an example of how your product is being used? Is it being used at some border patrol and at the airport checkup, or what could be an example?
Actually, our product could be used in many places, as you mentioned it as well, in airports, for example, for the check-in before the flight. But mostly our customers are financial institutions, gambling companies, travel companies, loan companies, credit companies, banks, because I could say that whereas on 2015 there was new regulation in Europe, which are saying that you must identify the customer if you would like to open the account for them remotely and everything else. So yeah, so in by such regulation, the product like ours is must use. So that is yeah where we are used, and yeah, mostly the companies which are dealing with fraudulent transactions, the credit card fraud, and yeah, other frauds are our customers.
Nice. So, for example, companies like Revolut and other financial institutions that require that you send your photo and a photo of your ID before you register. So some of them has identify software behind it, right?
Yes, that's right. Yeah. So you have to send the ID, you have to take the selfie of yourself, and this is how the identity verification method is completed. Yeah.
Nice. Okay. So Daiwa has a question, and it's a brilliant question, by the way. I would like to ask: is a face comparing algorithms? Are the face comparing algorithms considering aging factor? Because ID documents may store the photo of someone who's now 10 years older than in the photo. So how do you deal with that?
Yeah, so we get from the biometrical recognition system, we get as well information what is the range of age range of a person. So we are trying to compare, for example, if a document is issued 10 years before, and we see that the biometric systems and aspects, for example, very similar, different. So we are just dropping out the match rate, and this is how it's more. In such way, we can, let's say, more accurate to say if a person is similar or not.
Mm-hmm. And face spoofing and using fake faces to go around identification. How do you work on that? As I know, I visited Neurotechnology, and Liveness is going to present us next from Neurotechnology. I remember talking with the guys there, and they said that it's one of hard challenges to do face spoofing, and for example, to not to take a printed paper face printed on a paper as a real face. So is it a big challenge for you, technological challenge? Because it sounds like you kind of find a solution for that.
Yeah, so there is the two methods. So it's called one passive liveness detection. So the passive liveness detection is when you're just trying to see from one photo is there a spoofing attack or not. Mm-hmm. And another is active liveness detection. So yeah, for example, passive liveness detection is a really hard task to find out. It is possible, but once you use different cameras, different environments, so there is very much changes in the pictures, and it's hard to say this picture is real or not. But once you employ the active liveness detection, the person has to make some movements with their face. We have to do some things to ensure that to complete the process. And yeah, I could say that active liveness detection in nowadays is actually bulletproof. So it's not possible to bypass it.
Okay. Sorana is asking a few questions. So, would you consider your business innovative and disruptive in the field? Are there similar solutions available on the European market? And how do you leverage against your competition, against your competitors? So, what's your secret in competing in this field?
Yeah, the market is very crowded. There is very much competition here. But what we do, so we are making some differences. As I mentioned it, for example, we are not doing the 100% automated solution. Yeah, so we as well supervise artificial intelligence results. Because unfortunately in this area we cannot nowadays say that we can trust 100% what artificial intelligence are saying, you know, in the identity verification. Yeah, so this is why we are supervising it. So this is, let's say, some different part comparing with a competitor, because some competitors are doing only manually everything, so we are not employing artificial intelligence. Some is doing 100% with artificial intelligence, so we are doing like in between, you know, so we're doing a little bit manually and a lot of with artificial intelligence. As well, the difference are that we are connecting a lot of products around identity verification, as I mentioned, fraud prevention services, compliance services, and so there is a plenty products around it. So once you need the identity verification service, and once you come to us, we can, you know, give you a lot of things with it. Yeah, so this is our main difference.
Great. Since Identify is still a young company, as I can find online, it's 4 years old, already has almost 30 employees. So it's really amazing how you can compete in the field, since newer technology that I again mentioned that in some way are competitors of yours. I could imagine they are in the field for more than 30 years already. And I guess this work requires some trust and responsibilities that are required to be known in the field. So how come you are interested in this field of identification, Domantas, yourself? What background do you come from?
So our activity started in 2017. So our main road was to make the identification not only from the biometric identification, but we as well working in the field with, as I mentioned, the identity documents, anti-fraud services, and anti-money laundering. So we more working in the field where the regulations are saying how to identify the customers for the financial institutions. So I guess once we started, actually there was not a lot of competition what exactly we are doing. So because most of the companies with identification services was working with biometrics, and yeah, so our approach was full identity verification using identity document and biometrics. So yeah, so that's why.
Yeah, and I was reading that you have suggested the government of UK, United Kingdom, to create a immunity pass solution, as well as an app for following people who are in quarantine. So did that go well? Did you win the contract? How is it going?
No, actually, the government has selected other ways to fight with the COVID, and yeah, so that was not in our we didn't win that case.
Okay,
unfortunately.
but it was, well, was it worth trying?
Yeah, sure.
Great.
It was good experience.
Okay. Thomas has another great question. How do you address the ethical challenges that confront some AI applications? For example, there is quite persistent racial profiling in border security when human operators are involved. Is there a risk this bias can be built into your algorithms in order to satisfy the customer requirements? Great question, Thomas.
If I understood correctly, so yeah, so as I mentioned it, we do not make 100% decision. For example, if the person is the same or not. Yeah, so we employ in this process some part of the human to supervise this all the process. So yeah, if I understood that question correctly.
Yeah, but I think the question is, there are definitely some bias in human operators when they make decisions, when they make involvement, and if you move data that is made by humans, the bias can be moved. So how do you go around that? And another question I think is, are there any, let's say, well, let me think. Some willingness or desire to satisfy the customer needs, who could like maybe say that we need these faces to be more or less resistant to identification. Is there any risk in that you want to satisfy the customer requirements in this political field?
Actually, sorry, I don't get the correct question, but yeah, I think I can back to this question afterwards.
Okay. Yeah. Okay. So it's quite a Thomas. It's a great question. It's a big one, but maybe you need to read it all around. So let's just agree that you'll visit the chat and answer maybe Thomas straight back. Okay. Yes, and the last question I had, I think, is, okay, it's already, we are past time. So, okay, maybe let's move on with neurotechnology. Thank you very much, Domantas, since we are going to continue the same topic. So let's continue. So Domantas Čiuldė, CEO and co-founder of Identify. We'll see you, Domantas, at the discussion, and we are going to continue. Thank you very much. We are going to continue with Linas Petkevičius, a researcher at Neurotechnology. He works with research and development, and the Neurotechnology is a biometrics and artificial intelligence technology company. Linas is also a lecturer and researcher at Vilnius University. He's a board member of Artificial Intelligence Association of Lithuania. And Neurotechnology, I already mentioned it a few times. It's a company around 100 employees big here in Lithuania. It exports their solutions to all around the globe. It already has 31 years of research and development experience in neural networks, biometrics, and computer vision. It basically produces biometric solutions. You can check their website and see like how many different products they have and solutions already on the market. So this is not a startup. Neurotechnology is a biggie. So Linas is going to talk about real practical issues when deploying AI in the field in practice. Hi, Linas. Good to have you here.
Yes. So thank you for a kind introduction, and it's a really pleasure to be here. And today I would like to talk in general how the challenges appearing in providing the large-scale projects. We often have the problems when we deploying some kind of the smaller projects, but when we facing the large-scale projects, there's many more challenges that comes with it. And so today I will try to present that technologies which are created here in Lithuania and what are the challenges when we dealing with when we try to create some products which are applied at the world level scale. So shortly, just go by. So the company, as was mentioned, it was created in 1990s, and since then the main focus is on creating the biometric algorithms and the products. In order to do this, we're also creating various additional internal models based on AI technologies. And we're seeing that without the specific AI technologies, we cannot compete in the world level competitions. So from this point, I just want to mention that Neurotechnology is one of the leading AI research and development companies in Lithuania based in the biometric field. And one of the success points is that nearly half of the employees for us are working in the research and development field. So we always try to improve our algorithms and stay competitive in the global field. And obviously, it's not so easy just to have everything in one place, and we expanding slightly in all the fields. And for example, the company has branches both in Lithuania and abroad. And while the main products are creating the modalities of the fingerprint recognition, palm recognition, faces, iris recognition, voice recognition, and verification algorithms, and so on, we're also having multiple AI products which are complementing both the biometric products and other fields. So in this case, the newer technology is focused on creating mainly the software solutions, and especially the software development kits. In this case, it helps and allows the integrators in this field just to take our algorithms and integrate to the large, massive national scale products in their own projects. And the clients for mostly are foreign integrators which deploy the biometric solutions in the centers of the border controls, banking systems, time accounting systems, national border crossing points, voter registration system, passport assurance systems, and other national state level projects. And just a few projects that I will talk in my presentation, that even our current and ongoing projects are really worldwide scale projects. So in general, what kind of the problems are we solving? Those are usually quite simple ones if we just look from other point. So for example, if we just take the fingerprint modalities as example, so the quite a simple question could be, so how to create a simple fingerprint recognition system and how to deal with that, because fingerprints are quite a unique biometric modality, and we all have all the different fingerprints in our own. So usually we also need to create the idea and the algorithm which can look and find all the small details, those usually called bifurcations or the minutes. And usually if we just look at our fingerprints, we would see that various patterns we all having in our fingers. And those algorithms must be so clever to find and identify all the possibilities of the patterns in such that we could create some kind of the new representations. And this is not only the one and the first challenge. The second challenge is to create some kind of the representation which is so informative that we compare all the necessary folks and can do the identification or verification of the persons. But from this representation, from those templates, we cannot reconstruct the original data. And one of the common myths actually is that, well, if we do have some biometric data, that it is stored and can be stolen. But in fact, it's not true, because we're creating the algorithms which do the processing of them, for example, the fingerprints, select all the necessary information, store in some kind of transformation from which we cannot back and reconstruct the original information. So actually we're creating a really safe features and environment which can be used and for the biometric identification. And here with AI technologies come to the crucial importance. And so the typical AI usage in our case is by taking and applying the recognition models. And we always need to improve the models because it's not so easy. And when we create some kind of improved algorithm, it's not enough for us to test on our unseen condition in the real environments. And we're doing international testing by sending our algorithms to evaluate for the National Institute of Standards and Technologies, which is an etalon independent evaluator of the algorithms, which comparing the algorithms in context of the accuracy, speed, whether algorithms is biased in some characteristics or not. And in this case, we have the true recognition accuracy. And when we got the certification in this institute, we then have the ability to claim that our algorithms are in the top tier in the biometric field. And obviously, when we have improved the algorithm, then we try to optimize to achieve the maximal performance and even create the better product. And when we have the product, so we're creating the large scale systems where could be applied in practice, and we then seeing that those representations from which we cannot extract the information can be compared, and identification or verification tasks can be applied. So why it is so hard in practice? Obviously, the world is hard. And when we're seeing and creating the algorithms, various cases might arise. We will never create the database which will contain all the possibilities of the data in the world. So basically, we need to create the algorithms which are so robust and so good that they could extract the most significant information from the less amount of data as possible. And this is give us the major advantage. So obviously, it looks simple in practice, but it's quite a problematic and create huge problems, and we need to improve all the time our algorithms to be competitive in the worldwide competitors. So how good are we? So we are really good. And for example, we are known as one of the top biometric companies in the world, and we having various evaluations in really high rankings, and we basically having one of the top accurate fingerprint algorithm in the world, which is one of the most fastest algorithms in the world. And for example, we can compare like 1.2 billion persons per second to find the match, or 1.2 billion faces per second. And when we looking, our algorithms are applied in really large scale products. So what are those products that are used in the field? So one of the examples are our most flexible and the biggest products, the turnkey multi-biometric solution for the national scale identification projects. So it's called the Mega Matcher ABIS. The solution of this product, so basically can be adapted to all the functions that are necessary for the data collection, the biometric data collection, and the quality assurance. So when we talking about the biometric, first we need to know that data collection is really crucial part of the all the stages. So basically, when we first time collecting some fingerprints or in the government collection or the face photo, it must be ensured that there is no duplications, that the same person was not enrolled in the database in the first place. After that, the comparing billions of persons per second are just a small fraction of the functionality that we provide in such kind of the problems. And finally, we applying multiple functionalities like deduplication, other functionalities that are needed in this field, like detecting the liveness and the quality of the collected data. And those products usually are integrated in the biometric solutions of the border controls, banking systems, national border crossing points, voter registration systems, and other national state scale projects. So let's dive into the concrete examples, what the problems arise in applying such kind of the systems. So one of the previous projects that we finished was in the Congo voter registration project. And the country, which had over 85 million of the participants, wanted to achieve the main goal, to have the milestone, to identify and register all the unique persons in the country. And in order to do that, firstly, they collected all the biometric data of mostly all of the participants over the assumed age of 16, and then they needed to do the checking and to create the database. And what was done by our product, so within a 2 times period, they were able to perform the duplication. And what was really interesting, that they found that there was 5.3 million duplicate records. So basically, it's a huge percentage of the records which was really duplicated and bad and was not enrolled in the databases. And what is really important to mention, that there was a lot of exceptions identified. So for example, nearly 1 million underage persons in the data collection was tried to enroll in the system, but was not finally placed in the system. And this was done by the applying the AI algorithms. So for example, when we doing the biometric identification, we also have the ability to predict what is the predicted age of the person. So basically, if we're seeing that enrolled and take a photo taken is not in the range of the estimate of the that we gave for the person, so we click the alarm that it might be not the same person and it's probably something else. So we were able to identify those underage persons. So also we having the ability to check whether the person is what is their gender, and take into account whether to recheck and check for the duplication in those cases. So the other more fresh project is one of the largest projects in the world. So basically, it is called the Unique Identification Authority of India, and we are one of the companies that providing the solution. So basically, our algorithms is used to verify all of the persons in the India, which will be get the identification cards, and to do that duplication, and everything will be enrolled. And the numbers are just amazing. And when we looking that currently we building the system which will support the 1.3 billion persons to be compared at any moment, at any checkpoint when we person will go for the checking. And later in the version 2, we have the expansion to support the 2.5 billion persons within the database. And when we're looking from those numbers, we focusing and seeing that a lot of challenges. So at such scale, we're seeing that not only like a simple functional solutions and requirements must be met. So our algorithm must be so good that compare without many mistakes such numbers, but also to support many non-functional requirements. So for example, imagine if you have such kind and such large system, the availability support and the scaling of such system, and especially the quality of the duplication processes must be really fast. Because if we just have not only the manually but semi-manually process, it will take the decades to do the duplication. The process must be so strict and so precise that only the hundreds of thousands of the reviews must be done. So in such our products are extremely efficient. So on the other hand, we're having different kind of the challenges when applying the AI in the field, and one of the main illustrative examples could be our other product, which is centivalence. And in this case, we have the video surveillance product, which have the general object detection algorithm, which are able to detect the license plates, cars, pedestrians, and everything in one box. So basically, we can support out of the box everything just in one case. So if you just upload some kind of the videos, all the events of the detecting everything just comes to place, and our integrators then decide what is necessary for our cases to be identified. So for example, if there's person's recognition, so we have the genders, the ethnicity estimations, emotions, and so on. So basically everything can be detected. The same goes with the cars, the motorcycles, the license plate recognition, and so on. So in our company pipelines, AI is making a crucial impact, and we're using AI to generate new data. We use AI to detect the objects, identify and verify them, and even to speed up our data labeling processes, which is crucial for our data-driven algorithms to be even better. And it is a crucial technology in this field, and we're seeing that we need to improve everything all over and over again. And as I mentioned, for example, when we have the data-driven algorithms, so basically we will never to collect all the data in the world and all the variation in the world. And what is happening, we actually have the clever algorithms to generate new data, to generate new fake data, which are really realistic but are not real. So as an example, I place one of the algorithms that are commonly used to generate really realistic faces which are fake and not real, and we just have a lot of fake data which can improve our algorithms in the sense that we use additional data which is really realistic, but it also improve the algorithms. So as AI as a technology making a crucial impact in our everyone's lives, every time we touch some digital solutions, there's a really big chance that we have some kind of AI small part within that solution. And we see that significant improvements have been achieved in recent years. And this is a core ingredient in our success because we are using the data-driven algorithms to achieve more and more accurate algorithms. So in conclusion, I just want to mention that we are proud to have over 3,000 partners across the globe, and our products are in such form that are widely used. And we calculated that it was already touched by over 2 billion unique persons in the world that at some point was enrolled and compared by our algorithms. And we think that AI is really crucial and helps to develop those good biometric algorithms in the field. And as an example, we also seeing that data is really crucial in this field. And for this reason, we are also having even our own labeling platform, Synthesized AI, which are used for the data collection, data labeling, and we're using it in the house. So thank you for your attention, and maybe you will have the questions.
Yes, Linus, thank you very much. I'm stunned by the presentation. 2 billion people are touched by your comparison solutions. I'm wondering, do we have any other Lithuanian companies who work on such scale? And scales are quite amazing. The example with India that you're working on at the moment, system to support 2.5 billion persons. That's something. So thank you very much for an amazing presentation. I can see we have some questions in the chat. So first of all, yes, Taiva is asking, I see the biggest problem of the duplication of fingerprints is the large database. So is there a way to make comparison quicker? And how could AI be used to achieve it?
Mm-hmm. So one of the main reasons when applying such a large-scale systems is that while we have the good algorithms, the rules for the comparison cannot be applied directly. We need to have like multiple pipelines of the fallbacks. So for example, if the fingerprint is not matched correctly, or there's some multiple duplicates with the high scores and high similarities, we need to able to recheck automatically with the multiple rules. So for example, firstly, we use the checking of the persons who collecting the data. So for example, in those projects in Africa, we firstly check whether the persons who helping to collect the data, how those persons' fingerprints are enrolled in the database. Because as a quite a funny example, one of the recent projects in Ghana that over 17 million persons were done last year. So we had that every time when they collected the data, there was such cases. So for example, if the person had not a 10 fingers, so what to do next? And you need to enroll 10 persons. 10 fingerprints. So sometimes the persons who helped the collection, they just placed their own 10th fingerprint. And what you need to do is basically to have the additional safe rules to place in the automated process, that if the confidence and the matching is high and you're not sure is it a duplicate, then you just check with another database. If it's not in the database, you need to add another rechecking with the other attributes and so on. And then only then, if there's no chance to confirm whether it is a duplicate, even if it is in the fingerprints or the faces, then you go to the manual recheck. But it is such a small amount of the percentage that it is can be done really fast. But all the specific fallback strategies are encoded in our algorithms, and we basically can do mostly fully automated solutions, because we have, if it's highly to be a duplicate, we check with another algorithm and another algorithm, and basically we have such a small probability of failure that it is really acceptable by all of the project standards.
Yeah, so the answer is more AI in a way, so more algorithms. That, by the way, really quick fix that big people from Ghana think of. Funny example. Sorana is asking, and I can see she's really working on her research. So the question is, I'm curious about your view on the support. Oh, it's another question here. I already lost one. Oh yeah, I'm curious about your view on the support available in this field from European entities. Do you believe it is it available and easily accessible? I'm not sure if you are working with this directly, Linux, yourself, with the funding.
I'm not clear about the question. Maybe it is a question about the AI regulations and the accessibility to apply the algorithms in the field, or do you?
No, it's do you believe that the European entities, the institutions, they give enough funding for companies such as neurotechnology? That's kind of not a technical question. It's more of a funding question and available funds. But I think your colleagues are working on this, I would guess.
So I'm probably not the most qualified to answer to this, but on the other hand, for example, for us, we really rarely looking for the partners or the customers. We usually have a really good algorithms at really competitive prices, and all the integrators just found us by itself. So basically, we actually do not have even such amount of the resource to be looking for the new customers and so on. So basically, we're just growing organically. So it's not even an issue
Yeah, not really based on funding from European or other institutions. So thank you, Sorana, for your question. And Linas, I also wanted to ask you, you mentioned that your algorithms are being assessed by the National Institute of Standards and Technology in USA. I was very much surprised to hear that. It's the first time I ever hear a company that actually works with the National Institute of Standards and Technology. So can you tell us more about that? How does it work? I mean, do you send the code itself, the algorithms, and the institute is kind of, it has the qualities and all the knowledge to actually access your algorithms, and by doing that, don't you are you not afraid of giving away your commercial secrets, as some companies are afraid to do so?
So I will try to answer shortly, but the main steps and procedures basically are that the NIST, or the National Standard Institute of Technology, are independent evaluator. So basically, it defines the main goals and the main attributes. They will check the speed, the accuracy, whether the algorithm is biased or not on the ethnicity, age, and other factors. And they collecting not for say the code and the algorithm, but they collecting the programs. So basically, you need to send your own product, which have the specific API and the format in which they put the data, and seeing really hard cases from all around the world, the real situations, and they will check how your algorithm is working in the real conditions. And then they have every time, every company provide and update their own algorithm. They send for the evaluation, and there's always the leaderboard. So basically, one day you can be on the top, and after 1 week you might be on the second place, and you need to improve each and every year to be within the top.
Okay, that's interesting to hear. So thank you very much, Linas. Thank you for your presentation. Amazing to hear what does nanotechnology do in the field. So thank you very much. Really amazing. We'll see Linas also in the discussion. And now we are going to move forward. By the way, we can see, if you're interested, you can read Domantas' answer to Thomas in the chat about the AI and the ethical questions it raises. So Domantas answered the question and it all went well. And now we are going to have Kazimieras Sadauskas, CEO of Imint. And Imint is a cutting-edge computer vision technology startup working on a state-of-the-art AI solutions which automatically recognizes different models of military vehicles in images, videos, and real-time visual streams. So it's basically a visual recognition software, but does more than that. We'll hear about it quite soon. Kazimieras is a cybersecurity expert specializing in open source intelligent, cyber threat intelligence, and information security topics. And he's going to talk about AI and defense industry applications, challenges, and projections. So super interesting. Kazimieras, hi.
Hello, everyone. How are you doing today? Can you hear me well?
Yeah, we can hear you well. Good to have you here, Kazimieras. I know you're connecting from where? Not from Lithuania, I guess, right?
I'm above the Arctic Circle now in Lapland in Finland.
So, really?
Yeah.
Okay. Wow.
So it's already almost winter here. You know, the leaves are all already brown and beautiful colors, and maybe 5 degrees is, well, maybe 3 degrees. Yesterday is actually was already kind of snow mixed with the with rain, but hopefully it will get better. So this is how I choose to spend my holiday. I'm going out for some hike, you know, for 150 kilometers. But
wow, okay.
It's a pleasure to be here, you know, and to talk about us and AI. And I'm thankful for the chance to be here.
Yeah, so thank you very much for spending your time. You're sending your time on a holiday to spending some time with us. So computer vision for defense, we are super interesting and really nice to have you here. So Kazimieras, we are listening to your presentation.
Thanks a lot. So just to check or to double check, you can see the slides already?
Yes, yeah, we can see it.
Okay, so again, my name is Kazimieras Sadauskas. I represent Imint AI, and we bring AI to the battlefield and military intelligence. Again, I would like to thank again the organizers of the event for the invitation, and for all of you for coming to listen to us. It's an honor and a pleasure to be here in such company with companies like Neurotechnology, Identify, and all of you guys, of course. And before moving on with today's presentation, I would also like to say a few words about our company. So just to put it short, Imint AI, and Imint is an abbreviation which stands for Imagery Intelligence, and it's a common abbreviation used in the military sector. And so our company was founded early this year with the objective to create computer vision solutions for the defense sector. And so we are what one could call an AI-centric organization. And why? Because all the value we create comes from the AI-enabled technologies. To put it frank, we exploit machine learning and deep learning methods to create our own proprietary AI solutions, which later on are productized or used as components in the products of other companies. And although we focus on defense sector, our technologies can be used both in military and civilian sectors. And it is not a very big gap, let's say, between solutions provided to the military and, for example, for the solutions which are applied in the border control or object protection and other security-related verticals. We are heavily investing in research and development activities, as this is the lifeblood of our organization. So just as an example, someone was asking about the European funds. So currently we are focusing on the innovations for the European Defense Agency, and we are preparing to participate in a couple of European Defense Fund calls. We'll talk about that later on a bit, and as we will have a chance to talk about our technology a bit later in the presentation. So without further ado, I would like to jump straight into the topics we're going to cover today. So very quickly, first of all, we will talk a bit about the AI and defense industry. We will talk about applications of artificial intelligence in general, what and how AI is being used in the military section today. Then, as my own background comes from open source intelligence, we will talk about this a bit, and then again we will switch to what we are doing at Imint AI, and we will cover our technology and some, let's say, applications, what we are currently working on. So let's go on. So first of all, I wanted to bring matters into perspective with some information about the market sizes of different AI and defense-related industries. So the global spending on defense for the first time surpassed the mark of $2 trillion, and it is projected to rise even further up. And of course, the AI industry, on the other hand, is also on huge rise with an annual continuous aggregated growth rate of roughly 30% each year, and it should reach around $350 billion by 2027. Of course, I'm not talking only about AI applications for defense, but AI in general. And if we are talking about the defense expenditures, of course, what happens with AI and defense industry, it falls under that same number of $2 trillion. As one of the industries we are going to talk about today, and we as company, which we focus on, is open source intelligence. I also wanted to bring this number up separately, and as you can see, these numbers are quite substantial in the OSINT domain too. What is also important to mention is that all of the mentioned industries, of course, AI is playing bigger and bigger role. So let's jump into details on how the AI is used in the defense sector. So AI has emerged as the crucial component of modern warfare, as it possesses a higher ability to handle data, basically. By developing the ability to mimic human cognitive intelligence, AI enables a computer to apply knowledge gained from previous actions to improve its intelligence and decision-making capabilities. AI has become almost omnipresent during the past decade, and each year there are many more use cases than there were the previous year. And today, of course, AI is prevalent across the battle space, particularly around autonomous systems, although it is also increasingly used in the industrial domain, including, of course, for research and development, design and manufacturing, and support, sustainment, and training. The growth of big data analytics and the rising adaptation of cloud services in the defense sector are probably major driving factors which drive the global AI and defense market. And nevertheless, lack of expertise, unavailability of AI algorithms in some cases, and the high cost of setting up an AI infrastructure are among the few factors that still limit the market growth. And at the same time, of course, AI is improving planning, logistics, transportation across various sectors, creating a good opportunity for the penetration of artificial intelligence in solutions in the defense market. Artificial intelligence has gained serious traction within the technology community as a solution for complex problems, of course. Though it is already evident that robotics and artificial intelligence are entering a period of rapid advances. To give you a few examples, Google, Apple, Microsoft, and similar companies and many other, of course, smaller companies are competing to transform the vehicle transportation with self-driving vehicles. In manufacturing, autonomous production enables companies to adapt products to diverse consumer markets and other fields. This technology has had a significant impact on warfare since the Iraq War began in 2001. And unmanned drones provide sustained, for example, surveillance and swift attacks on targets. Small robots are used to disarm improvised explosive devices. And the military is currently funding research to produce more autonomous and self-aware robots to diminish the need for human soldiers to risk their lives. In the military sector, AI is used for autonomous targeting, surveillance and monitoring, security, cyber defense, cyber warfare, and other important military functions. And due to its high efficiency, AI is widely adopted in fighter aircraft, helicopters, and military fighting vehicles. Some of the emerging economies, as also the colleagues from neurotechnology mentioned, they use AI across the globe, probably, and incorporating AI in military applications to promote safety and security. And AI systems provide defense sector organizations with the many advantages and benefits against the traditional systems, if you wish. Just to give you a few examples, the integration of artificial intelligence with military transport can reduce transport costs and reduce human operational efforts. AI in target recognition systems improves the ability of defense systems to determine the locations of their targets or their goals. Systems equipped with artificial intelligence can extract medical data of soldiers and help in creating a complex diagnosis. Systems with artificial intelligence help defense personnel monitor their threats and thereby increasing the situational awareness. And of course, it is also very hard to underestimate the role of robotics in this industry. And AI in general and robotics, I think, will play a significant role in many defense applications, and potential use cases might include, for example, robots driven by artificial intelligence and which can travel through dangerous areas, perform remote operations, and most importantly, perform probably surveillance missions. Most importantly for us, because we are working in that industry. And manned aerial or maybe even ground or maybe water vehicles, in other words, also called drones, sometimes they carry the weapons such as missiles, and it's also used in drone strikes. But drones can also carry different payloads, let's say, which help with intelligence, reconnaissance, and surveillance missions. And of course, AI gives huge advantages when incorporated in image interpretation for identification and classification tasks, which is exactly what we are doing at Mint AI. Other use cases might include expert systems for diagnosis and maintenance of advanced weapon systems. So, for example, such as radars and missiles, automated equipment that get be used to provide precise support for aiming and transporting ammunition and accuracy. Cameras with, for example, with shock-resistant platforms that provide remote firefighting capabilities. The scope of the missile target and trajectory analysis to assess killing zones, takeoff time, simulation to help qualify rocket performance in different environments, better use of robotics for anti-improvised explosive devices, extraction of personnel, shooting from weapons and other uses. And of course, last but not least, AI-enabled security systems of defense system in general can easily figure out cyber attack patterns, for example, and develop tools to combat cyber attacks. So what about the AI and its use in OSINT activities, or let me remind you, open source intelligence? So in general, military experts, they agree that 90% of the information required by the intelligence community can already be found in the open sources. And when I'm saying open sources, these are, usual things like social networks or maybe news portals, etc., etc., etc. So the main reason for that is because we internet users, we are generating enormous amounts of data daily. And the only thing which stands in the way of extracting, let's say, the data, or maybe understanding what's happening with, or maybe interpreting that data, of course, it's technology. And so what about the AI technologies used in the open source intelligence applications? So first of all, I would say probably natural language processing, and which is a subfield of linguistics, computer science, and artificial intelligence. And this field, of course, is concerned with the interactions between computers and human language, and in particular, trying to solve the problem how to program computers to process and analyze large amounts of natural language data. And the goal is a computer capable of kind of understanding the contents of documents, including the contextual nuances of the language within them. The technology can then accurately extract information and insights contained in the documents, as well as categorizations and organization of the documents themselves. It is performed. Graphs, graph databases, and link analysis. So basically, in computing, a graph database is a database that uses graph structures for semantic queries with nodes and edges and some properties to represent and store data. A key concept of the system is the graph, or maybe edge, or relationship. And graphs can help to answer different questions. For example, what patterns are there in the fraudulent behavior? Which supplier am I most dependent upon? Who is the most influential customer? Do my products appeal to certain communities? Where is the bottleneck if you're trying to solve some kind of terrorist organization case? And so on and so forth. So many different applications. What is also very important is data enrichment capabilities. And basically, if we're talking about data enrichment, it is a general term that refers to processes which are used to enhance, refine, or otherwise improve raw data. And AI data enrichment refers to built-in cognitive skills and custom skills that add content transformation and generation during indexing. So enrichments, they create new information where none previously existed. And for example, extracting information from images, detecting sentiment, key phrases, and entities from text. These are just a few examples. Enrichments also add structure to undifferentiated text. all of these processes, they result in documents that make full text search more effective. And in many instances, enriched documents are useful, of course, for scenarios other than search, such as knowledge mining, for example. Of course, image detection and object recognition. So both colleagues who were presenting their solutions before they were talking about that quite a lot. Object recognition, of course, and one of the probably favorite ones, facial recognition, which is commonly used in law enforcement applications, but not only law enforcement, of course, but in many different scenarios. So what about us and what Imint AI is doing? So as it was presented before, Imint AI is a computer vision technology startup, and we are working on the state-of-the-art artificial intelligence solution, which automatically recognizes different models of military vehicles and images, videos, and real-time visual streams. And before we begin a deeper dive into the first application, let's say, or example for our technology, I'd like to shortly focus on the problem we are addressing. So as you remember, we have talked about the quantity of information which can be found in the open sources. And intelligence-focused organizations like intelligence agencies, like various armed forces, etc., they are actively exploiting, of course, those open sources to find the relevant information they need to possess. However, because of the screening, training, and many other recruitment processes, it usually takes more than 1.5 years since the beginning of the recruitment process until an analyst starts producing valuable intelligence. And as a result, there is a huge scarcity of intelligence analysts around the globe. And of course, the limitations we are talking about might include things like screening for the security clearances, maybe training, of course, the person. Of course, it is much harder for the government also to hire the person because the governments, they're competing with the private sector and so on and so forth. And as one of the examples of the first application for our AI technology would be to use it as a tool in the open source intelligence product. And such web platform would gather data from multiple social networks, analyze the visual content, what is found in the streams, streams of data. And then it automatically recognizes military vehicles and equipment in the images and videos shared online. And what basically takes days for an analyst, it would take a fraction of the second for such a system. Just to provide you several examples from our own experiments. So in these examples, we have taken images from the open sources, like social networks, and provided them to our AI algorithm to extract predictions, so-called, for the objects which are recognized in these pictures. I'm not sure if you can see, because these are quite in small numbers, the predictions, I mean, and you can see those under each of the photos. But as you can hopefully see, the results are quite convincing. The algorithm it was able to recognize military-related content with more than 90 and like 98. Well, maybe it's not a percentage, but it's easy to understand as a percentage accuracy. It is also worth mentioning that it can also recognize other non-military related content too. And at Imint AI, we strive to employ this technology to empower our clients in intelligence, reconnaissance, and battlefield missions. And if we dig a bit deeper into technology itself, of course, one of the main challenges for most AI systems is well, basically it runs into the amounts of data needed for the training purposes. And we have decided to use synthesized data for our training. And we use the high quality 3D model of the object we want to be able to recognize. Then we use it in synthetic computer environments where we can add basically infinite numbers of cameras or maybe other sensors, change weather conditions, daytime options, lighting conditions, different environments like mountain cities, deserts, forests, you name it. We can generate thermal footprint, LiDAR footprint, radar images, regular images, and so on and so forth. And then afterwards, this synthesized data is used for training of machine learning and deep learning algorithms. And then afterwards can be used to process the real life data, as in this example provided from today's Twitter stream, for example. We have quite a clear objective in mind, and basically just to create a library of AI algorithms, which would be able to detect and recognize 80% and more of the most popular military equipment models currently used in the world. And such solution can later on be applied in various products like combat vehicles, drones, sensors, and various smart devices like, for example, binoculars or thermal scopes used in the military. And several of potential applications, they include, for example, this is a project we are currently working on. Well, although the illustration is taken from another consortium, but what we are building now is the stratospheric intelligence, reconnaissance, and surveillance mission balloons, which are hanging, let's say, in the 20 or 18 plus kilometer height in the atmosphere, and then provide the surveillance, let's say, capabilities, the communication capabilities. So basically it is in that part of the atmosphere where nothing happens. Basically it's above the altitude where the drones or maybe the planes are flying, but below the satellite altitude. And of course it brings certain pros and cons when you are talking about the payload and what can be done with such an equipment. Tactical drones, so just to give you an example, if special forces operator team, it goes out into the field mission, they use the tactical drone, for example, to film the surroundings for a couple of hours. It brings back the video materials, and then it is a very expensive time for such highly trained individuals like the special operation forces are to sit and spend time analyzing this data. So let's say if the algorithm or let's say the software could annotate what's happening in the video stream and to mark the time where the certain objects and what kind of objects were recognized in this video, then it would be a big help. Combat vehicles, it is very important to understand what basically you are seeing on the line of sight in the battlefield. So basically, if the visual sensor of the combat vehicle gets an image of let's say an enemy vehicle, it is important to understand what kind of model it is. Why? Because this means that then you understand what kind of armor it has, maybe what kind of weaponry it has, how long or how far it can shoot, etc., etc., etc. Smart devices, so this I've mentioned before, this might be a smart binoculars, thermal scopes, maybe optical sights with integrated electronics, or maybe augmented vision, augmented reality devices, and so on and so forth. Of course, open source intelligence and maybe other data processing systems. So there are many means for the intelligence community to gather information. It's not only about open sources, but about many different sources as well. And to being able to automatically process that data and find relative insights is a very valuable capability. And with that, I would like to end. I'm looking forward to your questions. Also, if you ever need to contact me, please be so kind to do so. I'm also looking forward to your invitations on LinkedIn. And as mentioned, again, I'm looking forward to your questions if you have any.
Yes, thank you. Thank you very much for your presentation. Interesting topic, military and defense. We are now back to it. It's, by the way, I'm very much surprised that your internet connection works so well in the Nordic circle, but that's a big point. I was afraid you might get lost at some point, but coming back to the topic, Kazimieras, so I have a question. Okay, so your company is less than a year old. And your solution is not only a software, you also talked about implementing air balloons. I'm not sure if you have some partners to do it with or no, but sounds quite ambitious, which is great. But how did you get involved in this whole military topic? What's your background, and how do you start a company like this, just like from scratch?
Okay, great questions. Thank you very much. So just to to put everything into own places, we are currently focusing only on the software part and only on the analysis part, basically. So the balloon project, if you wish, or high altitude platform project, this is where we are participating together with other consortium members. So there are many partners which are responsible for many different parts in that very big project. So our responsibilities, they include basically the analysis part. So what kind of information can be extracted from the various sensors which you bring up by that balloon. And to answer your second question, it was always kind of a dream for me to work in the military sector. I don't know, maybe 20-something years ago or 20 years ago, when I was deciding what I would like to study and what I would like to do in work or in life. One of the main options was actually being a soldier and being an officer. Unfortunately, because of some, let's say, private reasons, I wasn't able to study in the military academy. So I switched to other activities and other sectors, but this let's say idea didn't let me go for many years. And afterwards, I started serving in what in some countries it's called the active reserve. In Lithuania, it's called National Defense Voluntary Forces. So for the last maybe 8 years, I've been serving also actively as a military staff member. And probably it was some kind of strange combination of various experiences which I had before, like working for a computer vision company, then afterwards working with open source intelligence and cybersecurity projects, and that passion for defense and innovations, let's say. So this was probably the main reason why it brought me to the idea of starting my own company. And we actually started everything, as you said, from scratch. We are a bootstrap company. We don't have any kind of external funding or something like this. So it's probably basically everything comes from the enthusiasm and the idea of providing kind of advantages and maybe some unique capabilities for countries like Lithuania, which are smaller, which have smaller budgets and smaller capabilities if you're comparing them to their relative adversaries, which we have in the East, probably, yeah. So our mission is to provide, Lithuania first of all, and other small countries which stand in the ways of bullies, with the tools where we, have, let's say, a force multiplier, so-called, and yeah, advantage which would bring us stand forward with our shoulders straight.
Mm-hmm. Great, thank you for your answer. And I have a few more questions, but
Lucas, I think I've lost you.
I'm here. Can you hear me? I can hear you. Yeah, Kazimieras, I can hear you well. Can you hear me?
Hello.
Yeah, I can hear you. Yes, I can hear you. Can someone else hear me? Because I can hear you well, Kazimieras.
Yes, now you're back.
Okay, yeah. Okay. Sorry. So I just complimented your internet connection, and maybe it went a little bit offside. Just have more questions from the chat. So Thomas is asking, what would be your advice to the armed forces of the Baltic states that are not really big data rich and lack large data sets needed by developers of AI-centric solutions? how can they stay in lockstep with the allies that are investing large amounts into AI applications for defense? Is cultivating small data concept and niches of excellence in particular solutions something to guide your defense investment policy in AI? So I guess the question, so to rephrase the question, because it's a long one, I think the question is how small countries like Baltic states can compete in a sphere in the topic where you need a lot of data to be in the front lines.
Yeah, so probably there are many answers to this question and many different angles to it. First of all, I think that what is really important is the partnerships, let's say, between the private organizations and the government entities. Why? Because, you know, basically in Lithuania, we as citizens, as country, we are quite strong in technologies. And I believe that it would be wise to use the, let's say, that potential which is gathered in the private sector, and that would empower the military sector, let's say, or the government part of the military sector to solve certain problems which they have internally. And very good example for this, I think, is what's happening in Israel, in the state of Israel, where all the people, first of all, they serve in the military, but on the other hand, in the military, they get certain skills and knowledge, for example, like in cyber warfare, in the same AI applications, in signals intelligence, and many other different topics, which later on they're transforming into successful and big companies in the private sector. And what starts as as military service ends up with a tool for your life afterwards to create, some certain businesses and start bringing value back to the country and to the military by creating some kind of unique solutions. So we don't have this ecosystem yet in Lithuania, at least not at the particular moment. Like, let's say, citizens who are conscripts, who come to serve in Lithuanian army. Basically, all of them, they are focused more on being kind of, just regular soldiers without developing some kind of their unique skill sets. So I think this is one of the places where we maybe should focus on. To answer the second part of the question regarding the amounts of data and about the cooperation. So first of all, I think it's very important to work with the partner countries, and it's of course it's NATO context and the same European Union context, and it's both a very good sign from the government perspective that the Lithuanian Ministry of Defense is involved in projects for European Defense Fund and PESCO initiative, Permanent Security Cooperation Initiative. I think it's translated like this. And of course, the NATO context. So there are many innovation projects happening there. And just to mention one priority, let's say, for the European Defense Fund is what is called frugal learning for the AI. So basically, it's how to train AI algorithms when having a very small amounts of data. So this is kind of one of the answers and examples to your question, is that if we focus on things or disruptive technologies or deep technologies, if you wish, which can change the way we work with the AI, this might be an answer to many questions we have internally as a country, and both as private organizations and as military.
Yeah. Okay. Thank you very much, Kazimieras. I can see some questions still are in the chat, but we are a little bit behind schedule. It's all good. We are going to steal it away from the discussion a little bit. No worries. Thank you, Kazimieras, for an interesting presentation, and all the best for the company, which is still a newbie here, but hopefully will grow fast. So thank you very much. Stay connected, and we'll see you in the discussion very soon. And we are now changing the topic, and we are going to space, since Marius Klimavičius, the CEO of Black Swan Technologies is about to join us. He previously worked as an engineer at the European Space Agency, and a few years ago started his own company. The company's products are designed to facilitate and foster the use of autonomy in order to manage the growing number of space assets. So what does that mean exactly? The two words that are very important here are autonomy and space assets. So Marius will tell us more about it. He's going to talk about AI in space, so and automation. So hi, Marius, good to have you here. Good to see you again.
Hi, Lucas. Thank you. Great introduction.
Yeah, so we are listening, and I know we are a little bit behind schedule, so don't worry, you have full 20 minutes. We'll just take it away from some of the discussion. So we are very much interested in what you have to share with us. So take it away.
All right. So at Black Swan, we're building autonomy in space. And today I'm going to introduce you to some of the aspects of artificial intelligence that we're using in our work, and talk a little bit about the future of space and the development of space technologies and the way AI could significantly contribute to that. So talking about those space assets that you highlighted, what does exist in space today? So we have big and expensive space stations, such as the International Space Station. We have space stations that are being built right now, which is the Chinese one, and the existing satellites for Earth observation and communications, as well as global positioning. On top of that, constellations from private companies like SpaceX and many others that want to be just like SpaceX are going to fill the low Earth orbit this decade with literally thousands of satellites to provide mostly global broadband connectivity, but also Internet of Things and Earth observation services too. So as a consequence, satellite numbers are projected to increase, actually more than tenfold, from the existing 4,000 to about 40,000 by the end of the decade. The core problem is that even to this day, satellites are predominantly controlled from the Earth in a pre-programmed way. And most of them only need to do station keeping, like those communication satellites or Earth observation satellites. So that's sort of enough for them to once in a while do a burn maneuver and maintain the same orbital height. But what if the satellite needs to navigate from point A to point B and perform complex operations such as repair, removal, or even building of something new in space? And that's actually where we come in. And in our solution is to create a software suite that will allow satellites to do work in space autonomously. Now, making satellites more autonomous would expand the range of activities they can perform. And here I'm specifically talking about navigation, relative navigation in space, related to satellite servicing and debris removal and other interesting topics that I'm going to talk about a little later. Also, having a higher level of autonomy will reduce the operational costs naturally through reduced human involvement in satellite operations. So there's less demand for, let's say, ground operations, ground control, when you're trying to control the satellite from the ground, and also the related ground communications network that has to be quite extensive if you want to do navigation in space. And last but not least, it will also increase the revenue for the constellation operators. So for the mentioned existing constellation operators, and for the new entrants like SpaceX and OneWeb and others. So basically, this will be done for the newfound ability to actually service the spacecraft, the thousands and thousands of spacecraft that they're going to launch and operate, repair them and extend the life of those satellites in orbit. Our vision, actually, the big picture, the big vision of the company is one where satellite autonomy helps build the necessary infrastructure in low Earth orbit and kickstarts the future space economy. And by this, I mean the economy in space. And this is basically something that is not dependent on what is going on the Earth, on the surface of the Earth. It's in space, meaning the end customer is in space, as opposed to the end customer being on the ground. So we actually share this vision with many great companies in the field, both from Europe and over the Atlantic in the US. These companies include Made in Space, Clear Space in Switzerland, Astroscale in Japan, Orbit Fab in the United States, and even bigger, well-established corporations such as Northrop Grumman, and Lockheed Martin, and Thales in Europe. So satellite autonomy will create all the necessary conditions for, firstly, the mentioned refueling of satellites that our partner Orbit Fab is working on in the US, which is basically giving the opportunity to refill the satellites with gas that is in orbit, removing the need to launch fuel from the Earth. And then, of course, you have the satellite servicing missions, and Northrop Grumman successfully carried out one mission last year and one this year. It was the first commercial mission to extend the lifetime of geostationary communication satellites, and there's going to be more to come in the near future. And eventually you have kind of exotic, but maybe not so much anymore, things like in-orbit construction that Made in Space is working on. So that's basically printing things in orbit and assembling things in orbit, and all of that requires high levels of autonomy and robotics. So within this ecosystem, our ultimate goal as a company is to become a go-to service provider for doing autonomous work in space, with our main value proposition, the main product that we're developing based on software. All right, so when we talk about navigation in space, or going from point A to point B to reach your target destination, it's usually in constrained elliptical orbits. So you can't go in a straight line. Well, technically you can, but you will be using a prohibitively large amounts of fuel. So usually everything goes in a sort of elliptical trajectories. This makes your movements more constrained, but at the same time more defined, meaning that you have the ability to plan maneuvers in advance quite well, and usually there aren't that many external factors that can impact your movements when you do move. So you can go from one orbit to the other, that is thousands of kilometers away by orbit transfers. This means doing a burn maneuver to raise your orbital latitude, and then doing another one to circularize the orbit once you have arrived at your target orbit. And when we talk about relative navigation in space, there is the concept of target chaser, where target is the passive object that you are trying to catch up with, and this is usually let's say a satellite that you want to serve as a customer satellite. You might want to replace or deorbit or inspect. And then you have your active satellite, which is your spacecraft that navigates to the target. And once you are at the target's orbit, meaning you matched each other's orbits, the close proximity operation phase begins, meaning that now you are anywhere from hundreds to tens of kilometers, as opposed to thousands of kilometers away from your target. And then you start doing something that is called rendezvous and docking. And this is usually performed for any sort of complex mission, again, that involves meeting of two spacecrafts, servicing a spacecraft, or building something bigger from smaller elements in space. So the first ever docking operation was successfully achieved in 1966. That was when Gemini 8, under the command of Neil Armstrong, rendezvoused and docked with an uncrewed Agena target vehicle. And this was done as part of the Apollo program that we all well know. We're trying to figure out how to get astronauts to and back from the moon safely. And then the Soviets followed shortly after, carrying out the first automated rendezvous and docking between two Cosmos spacecraft in 1967. Now, fast forward 30 years later, we have docking of Zarya and Unity modules. This was the sort of marked the start of building the International Space Station that hopefully, again, everyone is well aware of these days. So back in the 1998, this was just two modules docking together. Now we have a space station that is as big as a football field. And then quite recently, we had docking of the Crew Dragon. For those who were following the news, know that this was the first commercial mission that sort of brought astronauts into the International Space Station after quite a long period of time where Americans did not have any capability to do so. So bringing this talk closer to AI applications in space, we first have to highlight the fact that space is a different environment. So basically, things do look different in space because there is no atmosphere. Man-made objects look different. Shadows that these objects cast have very sharp edges, and you can observe strong sun glare or sun flash effects, just to mention a few of these differences. Things also move fast, so it is kind of hard to see if you're looking into space and trying to figure out where the next satellite is or where your target object is. When things are moving at speeds of 8 kilometers a second and more, it could be quite hard to keep track of them. And then, as already mentioned, things do not naturally move in linear fashion. You can get really confused as to where you are in space if you don't have a good reference point. The environment also changes quite rapidly. You can go from bright to dark, from daytime to nighttime quite fast. In a typical orbit in low Earth orbit, let's see where the International Space Station is, it lasts about 90 minutes. And in those 90 minutes, you're basically experiencing 24 hours of daytime, so daylight and night. And you're constantly doing that in those 90-minute orbit intervals when you're orbiting the Earth. So basically, if you want to rely on vision in space, you might get really confused. Right, so our current focus as a company in developing, is sort of developing the software for satellite navigation, plus all the related development pipelines that are needed for carrying out simulation and testing and prototyping. We're focusing on rendezvous and docking right now. As I mentioned, this is a sort of a cornerstone operation for any complex in-orbit missions. The docking and rendezvous software is based on artificial intelligence models and computer vision algorithms. We do have physical prototypes that we're developing, since you cannot really decouple software from hardware. In our case, hardware that goes to space has to be radiation hardened and have fault tolerance implemented. Plus, it has to be power and mass efficient. And we're also looking into robotic manipulation dedicated to carrying out complex tasks. So again, that sort of reverts back to in-orbit servicing and what you can do with one robotic arm. Ideally, you want to do multiple things and not to have several designs for different operations. So we're looking into things like using reinforcement learning to enable basically the existing hardware to perform better in space. And all of this is actually to prepare ourselves for a demonstration mission in space. As a space company, you want your products to work in space. This is quite an undertaking. Even launching things into space is expensive and challenging. So we're putting together a consortium of partners for this. Some of them I've already mentioned indirectly in the previous slides. Right, to give you a glimpse of our development pipeline with AI, or in this case, it's deep learning, the way we train, test, and apply it to our own needs. Well, all the models that we use, they're trained with synthetic data in simulation that we generate with our own in-house tools that we developed. And with those in-house simulation tools, we can generate any scenario in space. So varying from inspection to servicing with using robotic arms to debris removal and many others. And then we use those data sets, those synthetic images to train our models. And once we're happy enough with the way the models perform in the simulation, we're trying to take them to the physical world. We have the sort of rudimentary setup using scaled models. And some of you might recognize this specific CubeSat model or spacecraft model. This is from Nanoavionics. It's their flagship M6P satellite. That is our main sort of target for training AI models and testing them. And then the next step is, once we are happy enough with the sort of rudimentary results from the physical environment, we have to take them to the proper testing facilities of our partners. And that is basically involves running end-to-end space environment simulations. This might still not be with full-scale models, full-scale spacecraft models, but with much better modeling of spacecraft materials, surfaces, and the environment itself, such as the blackness of space, the dynamic lighting, to sort of simulate that quickly changing environment as you move around the Earth. And then even things like free-floating kinematics and dynamics in a 2D simulations. Right, and I guess the question is why use AI in this sort of applications? Well, the sort of advantages that we saw is the robustness, and again the robustness against things like dynamic lighting. It has the ability to learn features. Any of these AI models or deep learning models have the ability to learn features that would not necessarily be coded if you're working with a computer vision algorithm, or you would not necessarily think of coding them. So yeah, I mean, to deal with a sort of quickly changing environment, it does help to use something like AI. On the other hand, of course, as any technology, artificial intelligence does have its own limitations, and specifically when talking about applications in space, AI is resource intensive, so you need quite powerful computers to train the models, and also you need quite powerful computers when you deploy them to run them when they're based on vision and you're trying to process many gigabytes of data, visual data, of images. So this is a problem in space because you have limited processing power, you have limited electrical power, plus you have the thermal dissipation problem because there is no convection in space, so everything has to be radiated away. You have to be really careful, how much sort of power you're putting on your satellite. If you put a PC GPU, a game GPU, this would likely generate too much power for the spacecraft to dissipate, and then you're just overheating the whole system, and that's the end of it. Then of course you have the sort of real-time problem, because any software that goes into space, especially that has to do with navigation and robotics, has to be it is time critical. Basically, what that means is that many sort of standard libraries that people use for AI development or frameworks that they use for AI development and testing, they don't have this real-time compatibility, which means that they don't guarantee that, let's say, if you need to do something in 1 second, it's going to be done in 1 second and not more. And this is again a real problem in space because you don't want to mess things up in orbit. You don't usually have the opportunity to retry. I mean, if you miss your burn maneuver because your AI model messed up the pose of the target satellite, you might just slam into it, and that's the end of it. You just generated a massive problem. You lost the customer satellite, and you likely generated a space junk problem. So that's very important to get those things right in the first go. And then actually nobody wants to have this sort of black box that kind of works or maybe works. You have to make sure that it is reliable, and it's very reliable. 98%, 99% accuracy is not enough. You have to convince the customer that you're servicing in space. You have to convince the agencies, the European Space Agency, NASA, and whoever is giving you the permission to launch the mission that you're not going to mess things up again. People are still sort of kind of wary about, AI is this sort of black box that you put something in and you get something out. So there are some also misconceptions, of course, but you have to deal with these things when designing systems to work in space. And again, just to stress it out, space is a different environment, so you can't just easily, let's say, take something that works on the terrestrial applications, let's say, autonomous driving or drones, and then just slap it onto a spacecraft and hope that it works, because it's not going to work. And even the problem of the fact that you can't just easily test things in space. You have to design these facilities that are hopefully as close as possible to that space environment, but they're never 100% accurate. So you have a domain gap problem, which is a well-known problem actually in the industry, in the artificial intelligence industry, but it is specifically prescient, I would say, to space, because again, you don't have access to the ultimate environment easily. You can't get there easily. And it just, again, to perhaps show instead of tell, the picture that I'm showing right now is from the European autonomous transit vehicle docking with the International Space Station. The image is overexposed, so it means that all the objects are actually much darker. You wouldn't be able to see almost anything if you were the AI algorithm, looking into the International Space Station. In this case, also you have this variable environment, and in events such as firing of thrusters, you're basically firing the attitude control thrusters to make sure that you align firstly, and then dock with the International Space Station, and that creates gas plumes, and those gas plumes can also confuse your AI algorithms. So you have to make sure that you account for these cases when you're developing your models. Right, and then again, sort of thinking about the future of AI and how it can contribute to the I'd say the next phase in the human exploration of space, and then building this space economy, as I mentioned. Well, firstly, we have to again verify and validate AI for these critical applications, the critical operations, so that everybody's confident that your algorithms, your models are going to work as expected, and eventually phasing out the sort of involvement of humans on the ground trying to control a spacecraft that is thousands of kilometers away, which in itself is very hard. Then there's the problem of the lack of images. Kazimir has talked about a little bit about it, in the defense industry, in the AI industry, it's even more sort of pronounced, I would say, because again, the sort of problem is that you can't easily collect that data, the real in-field data. If you're just looking to the Earth, you're performing some sort of an Earth observation mission, there is enough data for that. But if you want to look at another spacecraft in space, that data is very, very hard to get hold of. There is a question of maybe using sort of combined approach. So when you combine AI with a more tested and more perhaps reliable models, for controlling the spacecraft. So you have AI that is just sensing the environment, and then you use a more deterministic control algorithm for actually controlling your spacecraft. But then again, you have to make sure that that sensory information that is coming from your AI model that is doing post-estimation or segmentation is accurate enough, and actually highly accurate. And then again, there's the sort of lack of right now powerful enough computers that can also work in space. So space-rated hardware that can run deep learning algorithms is really a problem, because you don't have half a kilowatt of power. As I mentioned, you have power in order of tens of watts. So essentially, you're trying to run your deep learning algorithms on an electric bulb, and of course that's something that you have to deal with, and you can go about and compress the models or optimize them. But also you want to make sure that you maintain the accuracy when you do that. So yeah, and I mean, if you want to do interesting and challenging things in space, and not just one-off missions where you do something, you say, great, I've done this docking experiment, or I've done this sort of debris removal mission, and then that's it. If you want to do things at scale and continuously keep building that infrastructure in orbit, then artificial intelligence can really help, because you need high levels of autonomy for that. Right. So I think with that, that's what's happening sort of in Lithuania with respect to developing AI for space applications. And I hope you enjoy this short overview, and thank you for listening.
Yeah, thank you, Marius. Marius, we surely did enjoy the presentation. What a complex subject, and getting around in space, I can imagine it's not very simple. We cannot use Google Maps, and the complexity of the problems you're working with is kind of it's amazing. So thank you very much for sharing what you've got. We have a few questions, so I want to go straight to those. First of all, Daiwa is saying that she liked your presentation a lot. Autonomy program sounds like a great solution for clearing the space garbage to clear near space for future launches. And Thomas is asking, what are the potential uses of your AI-enabled autonomy solutions to protect space assets from hostile actions that are weapons fired from Earth and so on? Do you have any plans? Are you working on that?
Yeah, that's a good question. We haven't directly worked with that, but we're looking into it. I mean, any sort of application can be used both ways. It can be used for sort of commercial applications and also defense applications, and definitely AI can be used for both. And it could be very useful to sort of track what's going on in space, because as I said, you cannot easily know what's actually going on. So if you have cameras in space that can see other spacecraft, that can sort of at least get you a glimpse of what's going on in orbit, that's very useful for, I think, both the intelligence community, but also the operators of the satellites that operate them.
Yeah, thank you. And just a short question from me. So could you share your timeline, your business timeline? I know that you just started the company a few years ago. So how long did it take to take in how many people, and at what stage are you in, and what kind of funding are you getting? How are you surviving at the moment? And at what point do you think you're going to break even or bring some profit into the company?
Yeah, hopefully sooner than later with the profit part. But yeah, I mean, for any space company or any space startup, bringing revenue is a challenge, because just things take such a long time to develop. So you're basically dealing with cutting edge technology. You're trying to validate it for space, and then again, as I said, something that works on Earth is not going to work in space. So you have to deal with that part. You have to deal with you have to go through all the development phases. There are 9 development phases as agreed by the space agencies and most of the commercial companies, called the technology readiness levels, and it usually takes years to get from TRL1 to TRL9, where you're basically operating something in space and generating revenue. For our company, we are almost, I'd say 2.5 years old right now. And I like to say we're planning to do the in-orbit demonstration mission, meaning we're going to launch our technology and test it in space in 2023. And then hopefully the the revenue streams are going to come in soon after. Obviously, we're looking into other ways how to sort of generate the revenue in the meantime. So we're looking into commercializing the tools, the sort of in-house tools that I mentioned for simulation and AI development, because there are quite a lot of companies that are trying to do the same thing. So helping them in any way, and then us generating a bit of revenue from that is the plan currently.
Yeah, so hopefully it happens soon. It doesn't take too long. So thank you very much, Marius. If you ask questions, I would like to ask more, but we should get going with the discussion. So thank you very much for your presentation, and let's connect now all together for our roundup of all of this. Thank you very much for connecting. I know we are a little bit behind the schedule, but we'll do a quicker one this time, since I basically have a few questions for you, but I want to ask all of you. And I guess now everyone can see us. Yeah, almost. You'll be able to see us all very soon. So defense, security, and space, these are different topics, and it's hard to put you all in one bucket. I can imagine you're working in different ecosystems, and also all these fields are very global. So my question is, and I would like each of you to answer, does working in Lithuania means you anything? Does it change anything that you're Lithuanian, you're working from Lithuania, not from, I don't know, Finland, Netherlands, USA, or Israel, or any other country? Is there anything unique in your field that makes your work kind of different from others who work in other countries? Since we are rounding up the Lithuanian AI global system, as the question I would like to ask, and maybe Marius, you just finished and you're the only one in the space topic today, representing space. So what does it mean to you to work in Lithuania in this field?
Yeah, I mean, there are, again, certain disadvantages, as all the other kind of speakers touched upon, lack of infrastructure, maybe lack of funding when you're developing these cutting edge technologies and trying to commercialize them. At the same time, since Lithuania does not have, let's say, history in space, I mean, people are quite ambitious, so they don't have the sort of preconceptions of somebody that is from a spacefaring nation, as the US or Canada or UK. So I'd say we are probably more prone to try out crazy ideas, and because we're not constrained by what's been done before. And obviously, we have a very successful company in Lithuania, Nanoavionics, so that's good, and that sort of proves that you can do great things. You can have a global business in Lithuania. But at the same time, we're still not boxed in. There's still this sort of green playing field that we can shape in any form we want, and I think that's a great opportunity.
Yeah, and if I'm not mistaken, ESA, the European Space Agency, has to give some of the contracts to its member states, meaning they have to share it. If I'm right, I'm not sure. Does that mean so you can get some of the funding?
Yeah, the way it works is every country has a certain contribution to the European Space Agency. Lithuania is an associate member, so every year it contributes a certain amount of money, and if that has to go back, most of it has to go back to the country and the commercial entities in the country, also universities. So there's still competition, but it is more of a, if you define your strategic direction well within the country, meaning that you know what you want to do in Lithuania with space, then you can really sort of use that funding efficiently and remove the, let's say, the competition from the big prime contractors in Europe, like Thales or Airbus and all the other bigger players.
Yeah, so there are some certain advantages. What about the others? Kazimieras, I was thinking about you. Maybe you working in the military field. Does that mean you have some also, I don't know, some priorities in some contracts because I don't know of some reasons? Doesn't that work the same way?
So, to put it frankly, of course, for every company, there are several major, topics which are of paramount importance. Of course, one is funding. Another one is probably kind of an ecosystem, if you wish, you're working in. And this is especially, I think, important in the industries we are talking about, like space industry, or maybe in our case, defense and military industry. So let's say in Lithuania, this ecosystem is not very developed, I would say. There are companies, of course, working in the field, and some of them, they're really old and established companies, let's say like Elsis. There are some R&D companies like Baltijos Pažangių Technologijų Institutas, how we call it, the Baltic Advanced Technology Institute, which are also working in the defense field with their research and development projects, etc. So on one hand, this, let's say, not infrastructure, but ecosystem, it exists. On the other hand, if you compare it to other countries which are really developed, let's say, in this defense industry, like Israel or United States or UK, etc., we see that there are many things, on which the country could improve. And on the other hand, there are some good signs in this direction. Just to give you a couple of examples, one is that the military investment fund is being created right now, and it's now under the evaluation of who's going to be the manager of that fund. So basically, the Lithuanian Ministry of Defense, they're providing, I'm not sure, about 13 million euros, if I'm not mistaken, and very much the same amount should come from the private sector. So basically from the venture capital companies which are willing to let's say manage the fund, the investment fund. And what's going to happen, and this is going to happen probably next year. So if any one of you were listening to this event or watching it online, if any of you are interested in defense and working in defense industry, so you should pay attention right now, because what's going to happen next year is that there is going to be a series of pre-accelerators and accelerators for that military investment fund. And all of them, they're going to be dedicated for the defense industry. And currently there aren't many let's say startups working in the field. So I think this is a really good opportunity if you have ideas, let's say, and technologies which might be used in the defense industry. So this is a good chance to start working maybe on your idea. And this is basically a good chance to get funding.
Yeah. So what would be the right place to look for, to follow the news on this? I
think you can find the news in Vega site. Because they're the ones, yes, they're the ones who are providing the funding. They are kind of the portfolio managers, if you wish, or the funding managers. Yeah. So yeah, okay. I think, and of course, probably the MOD website, they're going to talk about this as well. Mm-hmm.
Okay, I'll share it in the chat so everyone who is interested can see it also, what we're talking about. And Vega is the place to follow the news that just Kazimieras has shared with us. What about others? Linus, you work in a company which is both global and the products are very much global all around the world. Offices in Sri Lanka and solutions in Congo, Democratic Republic, and Argentina, and South America, and so on. So what does it mean to you to work here in Lithuania? Does it mean anything at all?
Yeah, it's obviously mean a lot, and we especially are proud that we can bring us a lot of success stories from our projects, which are known widely around the world, to share the ability to create such products here in Lithuania, because the most of our research and development are here in Lithuania, in Vilnius, and we are really proud to share that we are creating the technologies here. But also, I would like to mention that we are also enjoying that from our experience and our sharing experience via some contribution to the AI community by the organizing meetups or something like that. We are also creating and strengthening the AI ecosystem here in Lithuania, and we really looking forward to strengthening the community and the ecosystem here, because what we're seeing that if there's a concentration of good technologies and good competencies in one place, it's eventually grows to a lot of places, and even we are succeeding, others are succeeding too, and this is in general good for the whole country. And for example, we are also quite proud to be as members of the Artificial Intelligence Association of Lithuania, which also is bringing all of the ecosystem here to one place. And what we're seeing that you can share all the competences within the ecosystem, and then it's bringing the synergy effect, and it allows to create even more new products by itself. So for us, it's really nice to be able to create all the products here in Lithuania.
Yeah, and to give back to the community. Great. I will want to ask something more about that, but just Domantas, what do you think working here from Lithuania? Does it change anything to you? Automated identity solutions from Lithuania, is it a sign of quality for your company, or do your clients even matter? Do they even care about it?
Yeah, from our perspective, working in Lithuania do for us a lot. I would like to start from first thing that here is we have a lot of good talents from development part. So actually, for example, with the same funding, if we start our activity to develop a product in the United States or UK, it would cost us much more, and the quality wouldn't be like we can get here in Lithuania. So I would like to say, yeah, that firstly, the talents is, I think, the number one. Another thing specifically from our direction, that Lithuania is one of the first countries who are integrating the regulations, for example, about financial regulation, the anti-money laundering regulation. So we were one of the first in the Europe which integrated this regulation. So that made for us to develop our product and to deliver to the market as fast as possible. And so we adopted, let's say, the product to the regulation, and that made for us a good things. As well, the local organizations like Bank of Lithuania is acting in the financial field very, very active. So we right now are second country in the Euro by the electronic money institutions and banking licenses. So yeah, for example, just a government institution which actually taking the customers to the Lithuania, our customers. So it's very good conditions for us. And yeah, and as well, what we see right now that the startup communities is very growing in the Lithuania, supporting organizations like Meta in Vega. So yeah, it's brilliant right now.
Yeah, so it's nice to hear you some kind of words for Lithuanian governmental institutions. I think they are not the ones who receive too many compliments when they do good, and there's always a lot of criticism towards government, I guess, in all fields. So that's nice to hear. So I just want to ask you a more general question then. So how do you feel about Lithuanian AI ecosystem? I know it's active. It's not a question. I know it's active, but do you think there are still some potential with this untapped, or should we be just happy about how it's going at the moment, and sometimes just maybe complement each other even more and just be continue with the path we are on? Since we had this Lithuanian Go AI topics about biotech and health tech, and that event we had some criticism towards the government, toward the institutions, the funding, not enough labs, and so on. And then after we had this event about AI and creative industries in Lithuania, we were where we were quite positive, and we said that even though you couldn't say there is a creative industries community in Lithuania, there are communities of designers, of programmers, of artists, and so on. Still, it's very active. It's very live, and there are much more things to be happy about than to argue and find the problem. So, how do you feel? Are there any specific things that you think should be done better, community-wise, government-wise, or should we be just happy about it and continue on the path we are on? And maybe in 10 or 5 years, we look back and say, wow, this was a really good time for AI and creative AI and defense and security and the space topics in Lithuania. So what's your feeling about it? And so someone can answer, I don't want to be specific.
Maybe I can tackle this one, just a very short perspective. I believe that there are many good resources for the people who are active and who are willing to learn. So basically the community is already there, and it's being led by the prominent people who are experts in their field, and they offer guidance, and they offer basically everything you need to become an expert in the field, starting from the very beginning and basics, if you're talking about the technological part of AI. But maybe the second thing I wanted to also tell is that I think it is important to think of AI not only from the technological perspective. And we should also dig into such things like let's say the law perspective, which regulates or maybe doesn't regulate the AI. What are the legal aspects of it? What are the moral aspects of it? How can we use or not use, for example, especially if we're talking about a defense applications and AI? This is one of the critical topics which is being discussed now in the world, and there are certain opinions that AI might be, a very dangerous tool if we are not using it responsibly. So the message here, or maybe my opinion, is that there are lots of parts of AI which are not even connected to the technology. So let's say if you are a person who is into, I don't know, culture or maybe some kind of humanitarian studies, etc., you can also work and really contribute to both the technological community, but also to the country itself, like Lithuania, and also to the world, if you paid attention to also those aspects which are not purely technological, if we are talking about it, AI.
Yeah. Thank you, Kazimieras. So just to reply shortly, at the moment I am working on a story about the AI, how it is being regulated in the European Union. It's going to be on Mokslo Sriuba, so that's just a short advertisement from me. If anyone interested, it's going to be in Lithuanian. Almost, I think it's going to be a 20-minute documentary. It's going to be quite along with comments from European Parliament and so on. And also, you mentioned, I think it's a very interesting insight that we need to talk about this, and there are Lithuanian even scientists who talk about that. For example, I just Googled again, it was Ieva Skurdauskaitė, who has a doctoral degree in politics, and she is actually researching autonomous weapons and the ethical questions about it. So just to reply that it's happening somewhere. Yeah, and anyone has anything to add? I think Linas, you were connected at some point. Yeah, sorry if I interrupted.
So, if we're just talking about challenges, so I wouldn't say that currently there's significant challenges that we're facing, but a few can be mentioned. So for example, for us, we really need to update and improve our algorithms, which are already good, to be even better. And for this, we are doing a lot of research, and our researchers are reading a lot of new publications, scientific publications, and following all the scientific news. But on this side, we're seeing that there's quite a limited numbers of research groups in universities, and while there's a lot of funding opportunities for the startups currently, there's not so much increased number of the funding for the scientific community. And what we're seeing is that there's a lot of researcher groups in other near countries in Europe with a lot of researchers within those groups, and we see reading a lot of papers from the Europe on new innovations about the object detection and the classification and so on. But we're having quite a gap here in Lithuania because there's not so much of the human resources and researchers in the fields. And this is slightly unfortunate. And the second limitation, I will say that there's a slight as you mentioned, gap between the communication about the regulations, because now we had having the General Data Protection Act, and we having the new coming AI regulations and so on. But on the other hand, we want to be competitive in the global field, and such countries like China, USA, Russia, and all the competitors in those fields, they do not have so much regulations. They could use more data or more testing in more various environments, and based the line where you could find some additional data or something like that, it could be communicated much better. So I would say there's a few things that we could find the ways to improve for sure.
Oh, great! I haven't thought about that. The communication side of the new laws could be better. Great, thank you very much, Linas. Domantas, Marius, you want anything to add to my question?
I actually would like to also agree with what colleagues has said. For example, right now, the GDPR is actually limiting some of the AI activities, as well as, for example, biometric data and other things. So from government, it would be good approach maybe to act more in this field, maybe because by the regulation, every member state in the European Union can adopt for example, biometric usage in the country with a separate laws. So I guess what we lack right now, so that maybe Lithuania is not very active in this field, so maybe this could be done a little bit better. So it's from me a quick feedback.
So you're on the same page with the others. And Marius, you started. Let's finish with you. You were kind of an outsider for some time, and you worked at ESA, and you had to come back to Lithuania. So was it inviting the ecosystem? Is it easy for you to get back on track? I mean, I know it's already been a few years, but still, how do you feel about being the part of the community?
Well, I guess, it's the sort of nature of the industry that we're working in. There aren't that many companies in Lithuania that do exactly the same thing, or actually there aren't any, as far as I know, AI in space. So it kind of feels lonely, but at the same time, we do have access to the global resources, and there is the community developing here. When I started the company, actually, I attended this community organized by Dovydas Chilutka, which is very good. Free AI courses, basically high quality, and it really helped me myself as a founder of the company, let's say, to understand what would be the challenges that we will be facing ahead. Because as an engineer, of course, I knew about computer vision and robotics, but AI was still like kind of a gray field, and it was really like Lithuania, somebody being really passionate about it and sharing their experiences, and that kind of really helped us to get on the right track from the get-go, as opposed to trying to maybe hire an external consultant, or trying to find information on YouTube, or even the space industry. As I said, maybe people are still kind of skeptical about AI, so like you wouldn't find that much information on using AI in space. But
Yeah, but generally, from what I hear from you is that okay, there are some things that could be done better, but otherwise, it's the community is kind of inviting. There are a lot of specialists in the field, and it sounds like it's fun to do what you do. Definitely sounds fun working with space and security and some other things. So. Okay, thank you very much, Marius. And I know it's already lunchtime, so let's not take much longer. Thank you all, guys, for this short roundup of the ecosystem, but and more importantly, with your presentations, to letting us know what are you up to, what's happening in the military, in defense, and in space, and in AI in Lithuania. We are going to have, for everyone who is still listening, we are going still to have 2 more events about Lithuania Goes AI. On 21st of this month, we are going to have agrotech, which is, I think, for me, is the most unexpected topic of these virtual events, agrotech. And what about the community in agrotech in Lithuania? What are the guys doing there? What are they up to? What are the innovations in Lithuania in this field? I have no idea at this moment. Next week, we are going to find out. And on 28th, we are going to have Lithuania Goes AI education. And we'll hear on how AI is being used in education in Lithuania. So thank you, everyone. Thank you once again. Thank you for all the great questions, Simona, Thomas, and others in the chat. Hope to see you next week. Thank you very much again, all the presenters. That is Domantas, Linas, Kazimieras, Marius. Good luck with defense. Good luck with space, and see you in some other events with the community. So thank you very much, and have a great lunch.